Okay, as a second application of logarithmic functions, we're going to look at what we call the Richter scale. So the Richter scale is a scale which measures the magnitude of earthquakes. And again, the way you come up with this measurement, which we'll use the letter m for magnitude, is using a logarithmic equation. So the m, this Richter scale measurement, is equal to the log of I over I naught. So I is what we call the intensity of the earthquake, and I naught is the standard intensity. So I'm not going to get too much into detail about how you measure these things, but the intensity you could think of like there's a device. I don't know what that device is called, and I don't know what units it measures in, but that device it sort of like would have a needle, and during an earthquake, that needle would kind of vibrate, shake back and forth, and the more it vibrates, the larger this intensity is. So whatever that units that device is using to measure, that's how they calculate I. For our purpose, it's not going to be necessary to know the value of I. We're always going to be comparing, so we won't actually need to know what I is. I naught, the standard intensity, that's kind of like the intensity right now, assuming you're somewhere where there's not an earthquake going on. You know, if that device was kind of sitting on a table where there is no earthquake, presumably that needle wouldn't be moving, and it would depend on how sensitive you set that needle to be. But there's a standard intensity which has been decided where that would be considered like there's no earthquake. So just to actually think about that example, let's say I was equal to I naught. So what's the magnitude of an earthquake, sort of if there is no earthquake? So we'll use this equation, and if I was equal to I naught, then I'd substitute I naught into the equation. I'd have I naught over I naught, which would be the log of 1, right? I naught over I naught would be 1, and we know that the log of 1 is 0. So the Richter scale magnitude of sort of right now, if you're somewhere where the intensity that you're currently experiencing is I naught, then that would be a magnitude of 0, which makes sense because that's kind of no earthquake. There isn't an earthquake presently happening. So we're experiencing a 0 magnitude right now. Okay, so here's an example. So in San Francisco, so somewhere where you often have earthquakes, you have an earthquake which measures a 5 on the Richter scale, which is a fairly good earthquake, fairly decent sized earthquake. What is the magnitude of an earthquake 3 times as intense? So we want the Richter scale measurement of this 3 times as intense earthquake. So, initially some people might guess, well, 3 times, so would it be 15? You take that number and multiply it by 5. But because of the way the scale works, you're going to see that's actually not the case. But if you think about intensity, sort of what's happening is that little device that's measuring sort of the vibrations in the earth, the earthquake, which is 3 times intense, that needle is swinging 3 times as far back and forth. Or if you're standing on, in a building, the building is swaying 3 times as far each direction, which that's quite a bit of difference. So that's a much more intense earthquake. But let's see how that affects the Richter scale measurement. So let's say let I1 be the intensity for the San Francisco earthquake. So we know that that was 5. 5 would be equal to the log of I1 over I naught. Okay, and the intensity of the second workout or earthquake would be 3i. because it's 3 times as intense. Sorry, 3i1. 3i1. So we want to get the Richter scale measurement, so m of it, the Richter scale measurement, let's call it m2, would be log of 3i 1 over I naught, because I've just subbed in the intensity. So now what I'm going to do is basically use my log laws to get this. So I could separate this as the log of, I could write this as 3 times I1 over I naught. You just kind of bring the 3 down here. And now if you remember your log laws, if you multiply two logs, that's the two numbers inside a logarithm, that's the same as the log of the first number plus the log of the second number. But notice that the second number here, log of I1 over I naught, that was equal to 5. That's the Richter scale measurement for the earthquake in San Francisco. So this is going to be just plus 5. So we get log 3 plus 5. So we just have to figure out what is log 3 and add that to 5. And if you do that, you get approximately 5.48. So it's 0.48 greater on the Richter scale, this earthquake, which was 3 times as intense. So what you see is, and that's the reason that it's not that big of a difference is because of the scale. We've scaled these numbers, so even though it's 3 times as intense, moving back and forth, it's only moved the Richter scale number up 0.48, less than half. Okay, so here's a second example. You have an earthquake of magnitude 9, so 9 on the Richter scale. How much more intense is this than the earthquake of magnitude 5? So the one in San Francisco, which we said had a magnitude of 5. So I can tell you this, a magnitude of 9 is huge. That's about as big as you're going to get for an earthquake. Most earthquakes, even really big ones, don't hit the number of 9. And if you look at it, you know, this is 9, this is 5. It doesn't seem that much. It's not even twice as big of a number, but what you're going to see is that's a significantly much larger earthquake. So what we're doing is we're comparing the I values, how much more intense. So that needle, how much more is that needle moving back and forth? So let I2 be the magnitude, or the intensity of the earthquake of magnitude 9. Remember, I1 was the magnitude 5 earthquake. 9. Okay, so what we're trying to do is figure out how much more intense. So we want to compare I2 and I1. And what the question said is how much more intense is I2 than I1? So we actually want I2 divided by I1, because that would give me how many times larger is I2 than I1. So the way I'm going to figure that out is I'm actually going to figure out the logarithm of that value. So I'm going to try to figure out what is the log of I2 divided by I1. And then I'll convert to exponential form to figure out what I2 over I1 is. So in order to do this, what I'll first do is I'm going to take this fraction inside the logarithm, and I'm going to divide each, or the top and the bottom. So I2 over I1. I'm going to divide the top and the bottom by I0, which is allowed because whatever you do to the top of a fraction, or the numerator, if you do it to the denominator, you haven't changed the value of the fraction. And now I'm going to separate this using log loss. So this is the logarithm of something divided by something. So I can split that into two logarithms and say that's the logarithm of the numerator, which is I2 over I0, minus the logarithm of the denominator, which is I1 over I0. But remember this here, I2 over I0, that's the Richter scale measurement of the second earthquake, which was 9, minus the Richter scale measurement of the first earthquake, which was 5. So that's equal to 4. So you have log of I2 divided by I1 is equal to 4. Remember, that's base 10. If I convert this to exponential form, that would be 10 to the power of 4 equals I2 over I1. 10 to the power of 4 would be 10,000. So I2 is 10,000 times as intense as I1. So just a the number 4 bigger on the Richter scale is 10,000 times bigger. So those buildings are shaking 10,000 times as hard. That needle is moving 10,000 times as much. So therefore, the second earthquake is 10,000 times as intense. This example here gives us a nice equation, which we're going to use sort of in other examples. So this one right here, so think about what that means. That means the magnitude of 1 minus the magnitude of 2. That was equal to the log of I1 over I2. This equation here will be useful. If you remember the first equation we gave, so all the way up here, this one here, this is your basic equation, and it compares the intensity of an earthquake to the standard intensity. If you want to compare the intensity of two earthquakes, so an earthquake 1 and earthquake 2, you can use this equation, which we just get from that initial equation, and kind of doing some log laws, but sometimes it helps to just start straight with this one. And we'll see that in the next type of scale as well.